and weight is being taken according to gravitational field strength should be multiplied by W is equal to mg, and it is measured in newtons over there. After that, we will have to go for principle of conservation of momentum. Principle of conservation of momentum. Principle of conservation of momentum over there, in which I can say, let's suppose there are two bodies of masses m1 and m2, which are moving with initial speeds like u1 and u2 in the same direction, where u1 is greater than u2 over there. And I say after the collision, when u1 is greater and u2 is smaller, then I'm saying after colliding with each other, what is happening? They are moving with speeds v2 and v1 over there, having masses m1 still there and m2 still there. Then we can write down there m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2 as law of conservation of momentum of an isolated system, in which the momentum is remaining as perfectly elastic before and after collision over there. After that, I will have to move towards, I will say, force, density, and pressure over there. For that one, when we are taking force, density, and pressure over there, for all of these terms, I will simply say here that first of all, what we will have to take, that is called moment. Moment is a vector quantity, and having the symbol tau, having the unit Newton meter, and it is turning effect of force over there. Turning effect of force over there. Turning effect of force over there, that is called moment over there. And if I take its formula here, then I will say moment is equal to force multiply perpendicular displacement. Remember that perpendicular displacement between the line of action of force and axis of rotation over there, and force is applied at line of action of force of the body over there. Here I can also have to go for principle of moments. Principle of moments. Principle of moments means clockwise and anti-clockwise moments. Clockwise moment will always equal to anti-clockwise moment over there when the body is in equilibrium, in which I can also state that sum of all the moments will equal to 0 over there. After that, I will have to move towards density, where I can say density is having its definition or like that, mass per unit volume is called density, which is having a scalar quantity over there, scalar quantity having unit kg per meter cube. And here I will also say, when you are going to talk about mass per unit volume, then remember that this if it is being taken for the density of irregular object, then you will have to take the glass or the cylinder in which the liquid is present, and this is the initial reading, and you are totally submerging your object here, and now the new reading is reaching above till here, and then getting the final volume minus initial volume, you can get that volume of that object, irregular object over there. But if the irregular object is given over there, then I will say, let's suppose I'm getting the sphere over there, the unique formula that is 4 by 3 pi r cube will be used for the formula of the volume of a sphere over there. Then we will have to move towards the pressure over there. So for pressure, I will say pressure is force per unit area. It is a scalar quantity having the unit Newton per meter square. And we can also say its unit can be taken as Pascal. 1 atm pressure is being taken 1 multiplied 10 raised to power 5 Pascal over there. If I want to calculate the pressure in hydrostatic pressure or pressure given in liquids over there, then I will say pressure in liquids will equal to rho g h. H is the depth of liquid, g is the gravitational acceleration, and rho is the density of the liquid over there. And if I after that I will go to talk about upthrust force, the force which is exerted by liquid water on an object over there, that will be taken as rho gv. Rho is density, g is gravitational acceleration, and v is volume over there. After doing the density, pressure, and principle of moments over there, I will have to move towards the deformation of solids, in which I will say the important key term there is Hooke's law, deformation of solids. Deformation of solids over there. Then I will say Hooke's law. Hooke's law states that the stress and strain are directly proportional to each other, or we can say force applied on any spring or elastic body is directly proportional to the extension produced in that body within the elastic limit. And if I want to use this manipulate this relationship in the form of equation, then I will write F is equal to Ke, where K is a spring constant over there, spring constant over there, E is extension over there, and F is applied force, or can also be being taken as the simple formation over there. And here I said I will have to go for stress. Stress is just like a pressure over there, having the unit Newton per meter square, and it is force normally acting per unit area over there is called stress. And the strain is the ratio between the change in length over original length, or extension over total original length, to be taken to show the strain over there. And it has no unit because it is the ratio between the two same quantities of length over there. After that, I will have to go for Young's modulus, where I say that stress is directly proportional to strain over there. And for holding this relationship, I will say stress is F over A. And for Young's modulus, I can use here E as an constant, and strain can be being taken change in length over original length. But if I want to make it Young's modulus as a subject, then I will say Young's modulus is equal to F multiply L naught divided by extension multiply area. This is the way how to go for Young's modulus over there. So this was the Young's modulus, and then we will, in the last for elastic deformation, I will have to talk for strain energy. Remember that if you are provided by area under graph in the form of F and X, then you are going with 1 by 2 into Fx. But if you are not provided in this format and you are provided with the X here, I am taking the extension over there. You can also write it 1 by 2 F E over there. E is extension. But if I'm not provided with F, I'm providing with spring constant, then I will take 1 by 2 K E square, where I have just substituted this force with this relation where I said F is equal to Ke over there. So this was your strain energy formation for the whole topic over there. In the next section, I will say I will have to talk about energy, work, and power over there. So first of all, we will have to take work. Work is a scalar quantity, which is the product of force multiplied distance over there, and its unit is joule. And if both force and distance are in same direction, then work is maximum. Otherwise, if some angle is involved, then we say FD cos of theta. And if they are perpendicular to each other, then we say the work is 0 over there. And when I will have to go that work done in case of piston. For example, you have a cylinder which is having the piston over here, and you are pressing it by force over there by exerting pressure over there, and it is getting a new volume over there. Then change of volume is present over there. Then your work is going with pressure multiplied change in volume to be taken into account. After that, I will have to talk about power. Power is basically a scalar quantity having unit watt over there, which can also be written as joule per second. And it is power is equal to work over time. Can also be written as power is equal to F dot D over T. Can also be written by using D by T as speed. Then power is equal to force times velocity over there. So this is the way how to go for power to be taken into account. And then I will have to go for efficiency. Efficiency is basically related to the main formation where I say output power over input power multiply by 100 when I am talking in percentage efficiency. But if I am talking only with efficiency, then I will take power output over power input multiply by 100 over there can be taken into account. After that, the basic formulas which you have also learned in IGCSE, that kinetic energy is equal to half mv square and potential energy is equal to mgh over there can be taken into the account in case of gravitational potential energy and kinetic energy over there. After that, I will also go towards the waves section where I will have to take the frequency. Now I am going towards waves section over there, in which I'm saying frequency can be taken as number of waves, number of oscillations, number of waves passing through a point, in 1 second is called frequency. And if I am talking about frequency relationship with time period over there, then I say F is equal to 1 over T. Its unit is hertz over there. And R, we can also take S minus 1, and frequency can be taken into account as in the form of relationship over there. And there I will also have to add the wave equation. Wave equation states that you will have to relate V is equal to F lambda over there. This is the relation for getting the velocity to be taken into account in case of wave equation over there, where I said V is equal to F lambda over there. And then according to intensity of a wave, I will say that intensity is equal to power falling on the surface area per unit area over there. So its unit is watt per meter square over there should be taken into account in case of intensity. And if I say that I will have to explain the intensity amplitude expression over there, then I will say intensity is directly proportional to amplitude square, where I will have to introduce a constant K as amplitude square over there. So this is basically intensity amplitude expression over there. And if I will have to go for Doppler effect when source is moving towards, now I'm talking about Doppler effect when source is moving towards the observer. Source is moving towards observer over there. Then you remember that the frequency is increasing. Then I will say F dash observer frequency will equal to fundamental frequency F into V over V minus Vs. So it should be smaller so that your velocity is going to get some value of 1.2, 1.3 like that. That should be multiplied with your original frequency as a fundamental frequency or original frequency, and you will observe the higher frequency over there. But when in case of Doppler effect, when source is moving away from observer, then I will say I will have to take my frequency of observer as original frequency over V minus V plus Vs. When you are adding the source velocity there, then it means your fraction is decreased over there from 1 and your frequency is decreasing in that case. After that, I will have to talk about Molasses law. Molasses law, which states that the instantaneous intensity is directly proportional to it being taken by the relation I naught cos square theta over there. So the variables which I have written over here, the I is showing the intensity observed, and I naught is showing the maximum intensity, and the theta is a presenting angle between the analyzer and polarizer over there. Theta is the angle between analyzer and polarizer over there. Polarizer over there. This was related to waves section. Now I will have to go for superposition also, where I will say that let's suppose we are taking the formula for the stationary waves on the string over there, and stationary waves when both ends of a pipe, like I'm taking a string, I'm making a loop over there, one harmonic. On the other end, I am taking both ends open pipe over there, where I am taking this form and I am taking this form. Both are having the 50% wavelength over there. In that case, I will say that number of harmonics can, by if I use the formula that the wavelength for n harmonics, then it will be taken 2L over n. It means that this double of the length will be being taken according to its number of wavelengths according to harmonics. And if you are taking for this n over there, then I will say for the wavelength, I will have to use 0, 1, 2, 3, up to so on in case of wavelength to be calculating out according to their length over there. But if I have to go for the same case, when pipe is given and I want to calculate the frequency there, then I will say go for your Fn frequency for n harmonic to multiply with nf1, and n should be representing 0, 1, 2, 3, 4 over there. And you can also take your frequency by getting nv over 2l. Frequency will equal to nv over 2l. You can use any formula which you want for wavelength or frequency given with the fundamental frequency over there. And frequency can also be calculated by using the fundamental frequency by using speed and length of that section. On the other end, if I say my one end is closed, then remember that if I'm taking one end closed, then I am getting the wavelength only lambda by 4. In this case, I will say here that I will have to use my wavelength as lambda will equal to 4L over n should be being taken over there. And for frequency Fn, I will write it n F1, but remember that my n for this case will be 1, 3, 5, means following the sequence of odd numbers over there can be taken into account. And after explaining this stationary waves formulas, I will say that I will have to move towards Young's double slit experiment over there. Young's double slit experiment. I'm not going towards the too much explanation how the variables should be taken. I'm just making a rough diagram here for you. Let's suppose I'm saying that these are the slits which are separated by some distance, and here is the source of light. It is striking over there in the form of laser, and I have a screen over there, and the distance between screen and the slits is being taken as capital letter D. The light of rays having the wavelength lambda over there, and I will also say that X, which I'm saying here will be dark, bright, that is fringe spacing are being represented by a small letter x, and on the other end, the distance between the two slits I am taking as a separation a over there. Then I say lambda is equal to ax over capital letter D, which is the separation over there. And I can also go for diffraction grating, where I know that d sine of theta is equal to n lambda. This is called diffraction grating over there, where I say d is diffraction grating, and lambda is wavelength, and n is number of orders, and theta is angle between two rays over there, can be taken into account while going for diffraction grating over there. After that, I will have to move towards electricity over there. In case of electricity, as we are familiar, the basic key terms over there, that first of all, charge can be taken into account. Then charge is measured in coulombs or ampere second will be given as current multiplied time over there, and Q is equal to I T over there, having the unit coulombs over there. After that, I will say here that the second thing, the most important, that is called electric current, which states that rate of flow of charge is like I is equal to Q over T. Rate of flow of charges through a closed circuit. Rate of flow of charges through a closed circuit is named as electric current. After that, by using this current, I will have to go for drift speed to be calculated out over there, where I say that the current is equal to NAVE. This was the relation which we can use over there, where V is the speed, E is the electron charge, A is the cross-sectional area of the wire, and N is showing the charge density with multiplying by E over there, and I is the total current flowing through that circuit over there. So I is the current, N is the number density, A is the cross-sectional area, and E is elementary charge, and V is drift speed over there. And if I say go for number density, like the small n over there, which I have written here, then n is equal to number of electrons divided by volume. Number of electrons divided by volume of the wire should be being taken. Then it is called number density, which is multiplied by elementary charge over there. After that, the basic key terms, that is called voltage, where we can say voltage is work done per unit charge, and its unit can be joule per coulomb or volt. For measurement of this, we use voltmeter, which is connected in parallel across the resistor of the circuit over there. And after that, I will have to move towards the power. In electrical power, I will say here the power is equal to voltage into current. Remember that, as you know, power is equal to work over time. I'm just multiplying and dividing by Q over there. Then I am writing here W over Q multiply Q over T. W over Q we know that is V, and Q over T we know is I. So electrical power formula can be derived by using this relation over there. After that, I will have to move towards P is equal to VI can also be represented by using Ohm's law over there. I square R can be taken as V square over R. All these three formulas, depending upon the data to manipulate for the calculation of power, can be used over there. And if I talk about Ohm's law after that, for example, Ohm's law is the law which states that voltage supplied across the ends of a conductor is directly proportional to the current flowing through that circuit over there. That is called Ohm's law over there. And Ohm's law is going to have a constant that is called resistance. Resistance is having the unit omega over there. And this resistance can be defined as opposition offered by the conductor in the flow of current is called a resistance of the circuit. And if I say the resistance to talk about along the wire over there, then for example, this is the wire. Okay, and this is also a wire over there. Then there is less length, greater area, greater length, less area, like that. Resistance is directly proportional to length and inversely proportional to cross-sectional area. And for holding this relation into an equation, we use R is equal to rho L over A, where rho is called resistivity of the material or specific resistance of the material over there. A is the cross-sectional area, L is the length of the wire, and R is a resistance of the wire over there. After that, we will have to talk about EMF. EMF is the chemical energy provided by the battery. EMF provided by the battery to accelerate the charge inside the circuit over there. Then that is W over Q again, having the unit volt or joule per coulomb over there. Also, after EMF, I will say EMF with the internal resistance if it is being taken. Then EMF will have a very famous formula or relation over there, where we say V plus I into small resistance R can be taken according to EMF. And if I take this man potential drop over there in the circuit by the man resistor, then I can manipulate this formula as IR plus IR, and I can be taken into common and it can be written R plus R over there. And from here, I can say this is the EMF man formula, which you will have to use in both paper 1 and paper 2 for different calculations. After that, we will have to go for Kirchhoff's current law, which states that current entering a node, this node is equal to current leaving a node over there. And this is also called law of conservation of charge. In many MCQs, many papers, I have observed this law of conservation of charge over there. That is called Kirchhoff's current law, and Kirchhoff's voltage law states that sum of all the EMFs and sum of all the potential differences is equal to 0 in a closed loop or in a closed circuit over there. After that, we will have to talk about the resistors to be connected in series, and for that one, resistance total we can calculate by R1 plus R2 plus R3 up to so on over there. For parallel, we will have to take 1 over R total is equal to 1 over R1 plus 1 over R2 up to so on can be taken into account for calculation of equivalent resistance in parallel over there. After that, I will have to talk about potential divider. Potential divider over there. For example, I am provided with some high voltage as V input across the potential difference input terminal over there. Then I will have to take it by using the resistor across which I am taking the output, like for example, I am taking R1 resistor over, I will have at least 2 resistors, R1 plus R2. Then we can easily say that it will be the V output of the overall circuit over there for acting it as potential divider over there. And after that, there is a potentiometer that is talking about the EMF with having the length of wire up to that, with total original wire will have EX, means EMF calculation method using the I am saying here potentiometer over there. And if I talk about potentiometer, it means this is the total way how to go for different ways. After that, I will say here in the last, which I will have to talk That is, according to particle physics, I will say if you want to calculate the number of neutrons, then you can implement that atomic mass should be subtracted by atomic number. Then you can calculate number of neutrons. And if you need energy in nuclear reactions, then you are using the formula of E is equal to mc square as Einstein's equation over there. Okay. Here I want to say that if I have to go for proper definitions and concepts, then I will say I will have to talk about error, like any difference between measured and actual value, then that is called error over there. Error can be systematic error, which is occurred due to faulty operators. And then if I talk about random error, then I will say the random error is going to happen due to repetition of experiments over there. But the error is coming, for example, you are measuring the time using the stopwatch over there, and you are repeating the experiment again and again, you will get the different values according to stopwatch over there. And then we also talk about scalars and vectors over there. Scalars are those quantities which have magnitude and units only. Vector are those quantities which have unit, magnitude, and direction over there. And if we talk about distance, that is the actual length of path over between 2 points over there. Distance. Then there is displacement. The shortest distance between 2 points is called displacement over there. And I can also say here that speed, average speed, velocity, uniform velocity, uniform acceleration, or uniform deceleration can be taken into account. You will have to revise the graphs of speed and acceleration, speed and distances over there, velocity time graph for dt and dts. If I'm taking the graph for distance along y-axis and time along x-axis over there, then if I say the body is at rest, this will be the first graph. If body is moving with the uniform velocity, then I will say my graph is going to be shown like in this form. Across here is distance and across here is time over there. If I am saying that the body is going with increasing velocity over there, then I'm saying it is going to show like the graph like this. This is also according to distance and time over there. If I'm going in the last with the number 4, if you are going with the decreasing velocity, then your distance time graph can be written as in this form over there. So these were the distance time graphs over there. When we are talking with the velocity time graphs, we will say at rest, at uniform velocity, at uniform acceleration, increasing acceleration can be taken into account for explanations of say different formulas over there. Then I'm saying here, if I talk about first law of motion, that Newton's first law, then I will state that every body will continue its state of rest or motion until no external force acts on it. After that, Newton's second law, which states that F is equal to ma, Newton's second law over there. Then in that case, when Newton's second law is given, then we can say acceleration is directly proportional to applied force and inversely proportional to mass of that body, and it can give us the relation of F is equal to ma as Newton's second law. After that, there is Newton's third law, which states that every action as its reaction equal in magnitude but opposite in direction. And remember that both action and reaction should occur on different bodies over there. And after that, I can talk about mass. That is the quantity of matter present in an object over there. That is called mass. And if I talk about inertia, the property of a body due to which it resists any change in its state of rest or motion, and it depends exactly on mass over the body. And after that, there is momentum, which we can say the quantity of velocity is called momentum over there, which is having the unit kg meter per second. Is being taken as in the form of momentum over there. And we can also say by using this momentum as force is is equal to rate of change of momentum over there. And I will also say that there is a gravitational field strength that I said that is weight per unit mass over there can be taken as gravitational field strength. And weight is the force which pulls the body to downwards to earth, that can be taken in the form of weight over there. And this weight can be taken as a force of friction is also present over there. The force of friction is a force which opposes the motion of a body, which opposes the motion of a body, is called a force of friction over there. After that, I can also say that there is a free fall case, like irrespective to the mass of the body, all bodies fall with same acceleration of free fall. So free fall, it is irrelevant that how much mass you are having, you will move with the constant acceleration of 9.81 meter per second square for showing this result over there. After that, there is a terminal velocity, like uniform velocity achieved under the free fall of the weight balance or air resistance. And we can also say that there is elastic and inelastic collisions can be taken. Moment I have already explained, and torque and center of gravity, principle of moments, conditions of equilibrium. For conditions of equilibrium, I will say that sum of all the forces acting on the body should equal to zero. Sum of all the moments should always be also be like this. Then I have explained density, volume, pressure over there. I have explained according to Hooke's law, limit of proportionality, elastic limit, stress, strain, Young's modulus, work, energy, power, energy, gravitational potential energy. I have explained principle of conservation of energy, which I can say energy can neither be created and nor be destroyed. And in that case, we can say that both are energy can either neither be created nor be destroyed, only changes from one form to another, only changes from one form to another. This is called our law of conservation of energy. And then there was wave motion, transverse waves, longitudinal waves. I think so you will be much familiar with the transverse waves, which were having crests and troughs, in which when the particles of wave move perpendicular to the particles of medium, then those are called transverse waves, which we can take water waves or electro magnetic waves over there can be taken into account. And in case of longitudinal or compressional waves, are those waves which are having compression and rarefaction over there. And the compression and rarefaction is going to alternate with each other to produce longitudinal waves. When the particles of the wave move parallel to the particles of medium, then those are called we can say longitudinal wave. Then there was amplitude, wavelength, phase difference, time period, frequency, intensity relationship, Doppler effect, everything is done. And one thing which I want to calculate uh, over here, that is a new term named as polarization. Polarization. In case of polarization, I will simply say here that polarization is the property of transverse waves. Property of transverse wave. Property of transverse wave, in which we can say which allows the wave to vibrate, which allow the allows the wave to vibrate only in one plane. Only in one plane is called polarization over there. And then there is a superposition principle in which we know when two waves overlap with each other, then the resultant displacement is the sum of individual displacement over there. I'm just writing here its name, principle of superposition over there. After that, I can also say that in case of stationary waves, there are nodes, antinodes, and opposite direction phenomenons. Then there is diffraction, and at the end, charge, electron flow, number, density, everything is explained to you, and factors in which I will also have to add one more for resistance. That resistance also depends upon temperature by showing that the resistance is directly proportional to temperature, resistance is directly proportional to length, and resistance is inversely proportional to cross-sectional area over there. And there is thermistor, concept of LDR, diode can be taken into account. Kirchhoff's current law, voltage law, EMF sources in series, parallel, everything should be being added over there. There are electrical symbols. After that, we will have to go for isotopes and alpha decay, beta decay, gamma decay can be taken into account. And at the end, there are quarks having the elementary particles, which I want to state you here. Elementary particles, according to that, elementary particles are available in the form of hadrons, like hadrons can be converted into baryons and into mesons. When we talk about baryons, they are made up of three quarks, and mesons are made up of two quarks over there. And for that purpose, I will say here that, for example, for three quark, we can take proton, which is having the quarks up, up, down, or we can take neutron, which are having up, down, down, as their charges over there are they working over there. And in case of mesons, I can say there are two quarks. One is quark, and the other one is anti-quark. Second one is anti-quark over there is present. In case of this, when I will talk about these quarks, then keep in mind that there is up, down, top, and bottom, and we can say strength and chrome over there can be taken into account. So for up quark, the charge is plus 2 by 3e, and after that minus 1 by 3e, and when he has taken for the top, then it was plus 2 by 3e. So all of these are having their values over there, and bottom is having minus 1 by 3e. Bottom is having 1 by 3e with negative sign can be taken into account for up, down, top, bottom. These are the anti-quarks and quarks which will be present in the mesons group over there. So I try to revise you according to the basic need over there, according to examination point of view. So stay tuned and kindly subscribe my channel so that you can be able to get the latest video paper solutions over there, and you can score a better result if you wish over there.